All right, here we go. One more with function operations. But really what this one is that it's the concept of the radical and the fraction, the rational function there. So the radical comes in the f of x function for this one. So this guy is, that obviously that's a radical. All right, so the f of x has a radical in it. And then the g of x is what we call a rational function or a fraction. And so how do we handle that? So we're only going to take a look at two of them. You're going to have a chance to kind of play around with all of them in the homework, but so the conversation here is what's the answer? How do you do it? Are there any tricks to it? And then what about domain? So we're going to do a straightforward one would just be addition and subtraction. And so that's the answer. So there you go. Like I just literally plugged it in. And yeah, we could simplify this further. Like we could take this further and, and take it out more. But that's it. I mean, at this point right here, the computer will take this answer. Bam, plus 1 over x. And we're going to stay with that. There's more to it for simplification purposes, but that'll work for what we need. Okay, we'll come back and talk about domain in just a minute. Now this guy right here, remember the division, that means that we're going to do f of x over g of x. So let's plug it in like we know. So we take our f of x, which is the square root of 6x minus 1. We put it on top. And on the bottom, we put our g of x, which is 1 over x. But you see, that's bad juju. You can't do that right there. You can't have a fraction. You can't have a fraction inside of a fraction. So what we do is, it's not really called rationalizing, but we got to get rid of this denominator right here. And so essentially, we need to multiply this guy, top and bottom, by something that will eliminate that denominator. And so what we can do is we can multiply by the reciprocal. Because now we have an x on the bottom. So if I'm just looking at just the bottom portion of this, the denominator of this guy right here, the x's on top and the bottom cancel, the 1's cancel. And so right now on the bottom, that gives me 1. All right? So we go to the top. Whatever we do to the bottom, we have to do to the top. So we multiply the top times x over 1. Well, no big deal. We rewrite that. That becomes x square roots of 6x minus 1 over, let me make it a little bit straighter, over 1. So we took the top times the top, and we just put that for grammatical purposes, we put the x out in front. So it's x times the square root of 6x minus 1 over our 1. Well, we know that anything over 1's just disappear. So the final answer to this guy is x square roots of 6x minus 1. All right, so there's the first challenge is when you're doing the problem for homework or, when you're working through this section is you've got to be able to do that. You got to understand how to work with rationals and radicals. Then comes the conversation of domain. So what is my domain, or how does my domain come about? Sorry about that. Let me get this moved around. So what is my domain going to be for these two guys? Okay, so let's address this conversation, because that's one of the biggest pieces for this lesson is where does domain come from? Like, what do we look for? Well, our domain comes from two things. It comes from our, if we have a radical or if we have a fraction. Well, we have both of those in this problem. So what we need to do is we need to look at those as independent pieces here. So when we have a radical, we take what's underneath the radical, and we say that it has to be greater than or equal to 0. When we have a fraction, we take what's in the denominator and we say that it cannot be equal to 0. All right, so under the radical, on the denominator. And by the way, let's write the word domain right there. So this is our domain. Spelling is not my strong point this morning. Let's get that right, because I know you guys start copying this stuff down and then people are like, man, you didn't know it's called domain. Okay, so let's take a look at this independently as two separate pieces, and then we're going to put them together. So we start off with the first one. We take what's underneath the radical, which is 6x plus 1, and we say that that's got to be greater than or equal to 0, meaning that I can't have a negative under my radical. I solve that. So minus 1, I get 6x is greater than -1. I divide by 6. I divide by 6. I get x is greater than or equal to -1/6. Now, I'm going to draw a number line to kind of help us visualize what's going on here with this. So, draw a number line right here. We're going to put 0 right there, and I'm just going to put -1/6. I'm not going to draw it to scale. I'm just going to put that number right there. I'm going to say that's -1/6. Okay. The graph for this guy would look like that. Okay. We go to the next one. We go to the next guy right here, and we say, okay, well, x is, I would look at our denominator. So we take the denominator, which is x, and we say x cannot be equal to 0. Oh, I just noticed something. Sorry, let me back up for 1 second. I wrote down right here the wrong equation. So instead of me going back and redoing this whole entire problem, notice right here that this is not a positive. I had a plus sign, that this is a negative, which changes this to a negative. I'm going to leave it as black, which means that instead of subtracting 1, I'm actually going to add 1. And that changes my graph, which I was kind of in a little bit of a panic, because now instead of being at -1/6, I'm at +1/6. So we'll just come over here on the positive side and we'll put down 1/6, draw a closed circle. Everything else is exactly the same. It's just that instead of being at negative, it's at positive. Remember, and the reason that is because I copied the problem down incorrectly. It's 6x minus 1. I had 6x plus 1 right there. Okay, so back to where we were. So in this case here, my x cannot be equal to 0. So that means we go to 0, we draw an open circle. Well, guess what? It doesn't matter, because the only x's that work for this guy right here are the x's starting at 1/6. So we have this spot right here where I can't be 0, but that's already in my region of my graph. Right? That's already in the region of my number line that doesn't work anyway, according to my first restriction that I had. So in that case, my solution, my domain for this guy is going to be, I'm going to start at 1/6, so I use a bracket, right? I'm including it because it's equal to, and I'm going to go to infinity. So my domain for this particular function would be 1/6 to infinity. Take a look at the next one. So our final answer in this situation was this guy right here, right? So we break him down, we say, okay, well, we don't have a fraction, but we definitely have a radical. So to find the domain, we take what's underneath the radical, which was 6x minus 1. We set it greater than or equal to 0. Remember, we've got those little rules that we kind of established there. Where we write them down? Oh, there it is right there. If you have a radical, you do greater than or equal to 0. If you have a fraction, you set it greater or not equal to 0. We solve it. So I'll do this one correctly. So +1 + 1. So 6x is greater than 1. Divide by 6. Divide by 6. X is greater than or equal to 1/6. So on a number line, if you need to, so we draw that number line again. We place the 0. We put a location for the 1/6. It's greater than or equal to. So from our previous videos, we established that that would be a closed-in circle. And it's greater than, so it would point to the right-hand side. So in interval notation, which is what my math lab is going to want, in interval notation, I would start at 1/6 and I would go to infinity. And that will be my domain for that function. All right, so that wraps up function operations. We'll go on. We got a couple more videos for this section.